Good morning or good evening, depends when you want to watch this video. We're going to look at chapter 8 now, and in particular the first topic inside chapter 8, which by the way is our last chapter for this class. We're going to deal with quadratic equations and how to solve them, in this case algebraically, which essentially means factoring. Now, let's start off with a very simple situation. If you have a quadratic equation that is already factored, and you're trying to solve quadratic equals 0, which is the most common version that you should do, this and this are called factors, and all you need to do then is find the value of x that makes this factor equal to 0, which is simply 3, or the value of x that makes this factor 0, in this case -4. And your solutions would be x equals, and then in web assign there'll be a little box, and you put the smallest one, comma, and the biggest one. And that's pretty much it done for you. Let's look at another situation where it is factored. Suppose I have an x minus 4, again equal to 0. The key here is to always have 0 here if you want to make life easy for yourself. Well, it's already factored, so this one is almost silly. What value of x makes x 0? Of course, it's x equals 0. And in this case, the factor is x minus 4, and the value of x that makes that 0 is 4. And so our solution, or solutions I should say, because there's two of them, is 0 and 4. So if they're already factored, as we have in these two examples, all you need to do is take each factor, find the value of x that makes it 0, and you've got one of your solutions, and the second factor, make it equal to 0, and you've got your second solution. So the next level up, because that's a pretty straightforward one, would be questions where you have to do the factoring yourself. So let's look at that one. Now, it's a quadratic, as all of these are. It's going to have an x squared of some sort, may or may not have an x's, and it may or may not have a constant term. If you only have x squares and x's, your factoring is going to be a common factor, in this case of x. What you're looking at is a situation pretty much the same as this one. So once you've got it factored, you then take each factor and find out the value of x that would make it equal to 0. So you want this factor to be 0. The value of x is -4. And then you would put down as your solutions, again there's two of them, smallest one first, comma, the bigger one. Let's try something a little bit more difficult. Suppose I would need to solve a typical quadratic. These are the most common. 3 separate terms, right? Some x squareds, a number of x's, and a constant term. So step one, when you have this type of situation, is to factor the quadratic. So in this case, I'll just rewrite the original equation. I need to factor x squared, take away x, take away 2. Well, since it's an x squared, I know that it's going to be x and x. I'm looking for two numbers that multiply together give me -2. So that kind of guarantees 1 plus and 1 minus. So two numbers that multiply together give me -2. And when I add those two numbers, I get -1. And that's the combination that works. So we've now factored it. We then move on to, once it's factored, at least, we then move on to step 2. And that is basically use the factors that you found to get solutions. Well, this factor is x plus 1, and for it to be 0, x would have to be negative 1, so that's one of my solutions. Or the second factor, which is x minus 2, could be 0, and the value of x that makes that happen is 2, and so your solution is going to be negative 1 and 2. So we've essentially covered questions up to number 5 right now. Now, when you have a quadratic with 3 terms, your factoring is going to look something like this. Let me show you another question where the factoring is a little bit different looking. So you've got t squared, take away 25 equals 0. So if you ever get a quadratic where there's a t squared or an x squared, whatever the variable may be, take away a number, and this number is almost always going to be a perfect square. You could factor it by recognize that this is what we call a difference of two squares. So what you get is you get a t and a t. And you're looking for two numbers, and the two numbers are going to be plus and minus 5. If you check that, if you multiply them together, you get negative 25. And if you add them together, you get 0. So it's still the same rule that we used. It's just a special case of it. So we now have one of the factors is this guy, and the value of t that makes it 0 is negative 5. And the other one, in this case, that's the second factor, and the value of t that makes that 0 is 5. And that gives us solutions of negative 5 and positive 5. And question 6 is similar to that one. So is question 7. Let's move and look at some of the more typical ones. Here's an example of that. Question 8. And we're back to y squared. Take away 16y plus 64 equals 0, which really makes it similar to question 5. But you're going to see in a few moments that it's just slightly different, but nothing major. And since that is y squared, I know a y can go there, I know a y can go there. I'm looking for two numbers that multiply together and give me positive 64. But when I add those two numbers, they should add up to negative 16. That pretty much guarantees that they both have to be negative. And the combination that gets me 16 is this. And what makes this just slightly different from question 5 is that when you look at the two factors, they end up being the same. Right? They're the same factor. Which means then when you come to solve it, there's only one possible solution. And that is that the factor y minus 8 has to be 0. And that will happen when y equals 8. And so in this case, your solution is just going to be a single value. Now, let's suppose I would like to check my answers. Obviously, you don't really need to check in WebAssign. It tells you if you're right. But let's suppose it was a test situation and I want to be able to check it anyway. This is what you could do. You substitute y equals 8 into this equation. And if, when you plug it into here, you get the answer 0, you know that you've got the correct solution. So this is going to be 8 squared, take away 16 times 8 plus 64. Well, 8 squared is 64. That guy times that guy is negative 128. And you add the 64. And yep, check. It works. Now, if I did this calculation and the answer I got was the left-hand side was 10 or negative 40 or something, that would tell me that the solution that I thought was correct was in some way wrong. Let's suppose that I made a mistake and I thought that the answer wasn't 8, but negative 8. Let's see if the check will find that. So y squared take away 16y plus 64 should be 0 if that is a true solution. So it's negative 8 squared, take away 16 times negative 8, add 64, should be equal to 0. Well, negative 8 times itself is positive 64. That guy times that guy is positive 128. And that guy is also positive, and it's plus 64. And if you put them all together, do you see that the answers don't match? That's 256. It's not 0. I know that I'm wrong. So that's how you would check in a test situation. Have I solved the equation? So for instance, over here, I would plug in -1 first and see if it works, and it does. Then I'd plug x equals 2 in here, and it does. So I would be quite comfortable that my solutions were correct. Now, all I'm going to do in the next situation is take essentially a normal quadratic like that and just rewrite it in a slightly different format. So this is a version of question 9. So r squared, take away 3r equals 28. Now what happens, or what people do wrong, is that they factor this, pull out an r as a common factor, and then make it equal to 28, and then somehow think that's going to solve it. It doesn't really solve anything. What you're going to have to do for every quadratic is make it look like this. It's its standard form. R squared minus so many r's, in this case 3, plus or minus a constant. In this case, the constant is minus 28. Now from that, you can then do the factoring. So because it's an r squared, it's going to be r and r. It's negative 28, so I know one number is plus and the other's negative. And so I go through all the combinations of 28 that I can think of, one plus and the other negative, right? So it gives me negative 28, but when I add those two together, I get negative 3. And the choice, and the only choice that works, is that. And you can FOIL that out to check that it's right, but 4 and negative 7 added gives me negative 3. 4 times negative 7 gives me negative 28. I know I got it. So if you can get it to there, the rest is pretty straightforward. You take each factor and you make it 0, and then you find what value of r, in this case, you would need to make that 0. You take your second factor and you set it equal to 0, and then you find out what value of r you would need for that to happen. And then you can take your solutions, and in this case, there's, well, it's pretty common, there are 2 different ones. You write them down with a comma, and you call it good. So another example of that same situation would be question 11. And in question 11, we're being asked to solve t squared, take away 64, equals 63t. Now again, you have a quadratic of it, these bits of a quadratic equals this. Don't factor that, that's not the way to go. First step will always be to subtract 63t from both sides. And now that I've done that, I realize it would be much better to rearrange it so that the t's are in the middle. So hopefully you can go from there to there in one go. Now I'm looking for t squared, so again, that's pretty straightforward, t and t. I'm looking for 2 numbers that multiply together, give me negative 64. So that clearly means 1 plus and 1 negative. And the answer that you get when you add the 2 numbers together is negative 63. So that's a pretty big combination. That's the one that works. So we factored it. We can now move on to the final stage. Set the first factor to 0 and figure out what value of t would make that happen. Or take the second factor, set it equal to 0 and find out what value of t would need to make that happen. And that gives us a solution, or solutions, of negative 1 and 64. And again, if you wanted to check, let's say you wanted to check if negative 1 worked, you would go back to the original equation and you put negative 1 in here, negative 1 in here, And whatever that answer ends up being, the same number should appear here. And check, you should check it, but take my word for it, it works. Well, what's left? Well, the only quadratic equations that we haven't yet tackled are the quadratic equations where this isn't a t squared or an x squared. It's when it's a multiple of the quadratic part. So it's a 4t squared or a 3x squared, that kind of thing. So first example of that would be question 12. So this time we have 2s squared, take away 21s, add 49, and it's equal to 0. Now, if you've done any, you have done questions like this before, because this is a 2s squared, one of them has to be 2s and the other has to be s. And we're looking for two numbers that multiply together that give me positive 49. But when I plug them in here and FOIL it out, I get negative 21. That means that I'm going to have a plus and a minus. So I'm going to go plus 1, negative 49, negative 1, plus 49. Then switch places. Plus 49 and negative 1, negative 49, plus 1. So that's just 4. Thankfully, 49 doesn't have too many other choices. There's a plus 7 and a negative 7. And if you switch places, you get that. Now there's 1, 2, 3. There are 6 choices here. But only one of them is going to give you negative 21 in the middle. Right? All of these choices will generate 2s squared. All of these choices will eventually get you plus 49. But what you won't get from all of them except one is that the middle term is negative 21. So I am going to go for, what am I going to go for? And I just made a oopsie here. For some reason I thought it said negative 49. It says plus 49. So since it's a plus 49, and that guy there is negative, I know both of them are going to be negatives. So it's going to be negative 1, negative 49. Or you can switch places, negative 49, negative 1. Or you can get negative 7 and negative 7. Anything else? Check it out. So negative 7, negative 7. You check that one, see what happens. Those two get you negative 14. That guy gets you another negative 7. That's the one that works. I'll just rewrite it again. So there wasn't that many choices, right? I only needed to figure out which one of those worked. And we ended up with these two factors. So I can now take this one, which is 2s take away 7, and it has to equal 0. And the value of s that makes that happen is 7/2. Or you take the other situation, which is a little bit easier. That factor should be 0, and the value of s that makes that up is 7. And so your solutions is going to be 7/2 and 7. Okay. Now, just to remind you, this is the combination that you would have to deal with if that was negative 49, right? Because if that's negative 49, both one of them is plus and the other one should be negative. In the situation that we are dealing with, since that is a positive number, that means that you either get 2 pluses or 2 negatives. And this middle term tells you, if this is negative, 2 negative numbers. If this is positive, 2 positive numbers. Okay. Well, if we move on to another example of this, there's really quite a few, but there are some. And they get a little bit more tricky each time. So here's a version of 13. 2w squared plus 11w is going to equal 6. hopefully we're used to the idea that you don't leave that as 6. So the first thing I'm going to do is subtract 6 from both sides. And now I'm going to set up the factoring. Now, this is the number -6. That tells me somebody's positive and somebody's negative. So it could be +6 and -1, -6 and +1. Then -1 and +6 and +1 and -6. And that's me basically got all the combinations of two numbers multiplied together in either order. You have to remember to switch places in the order. One of these four is going to give me 11W. So I'm going to put a 6 there because that will get me 12W. And I'm going to put the -1 there, which will take 1 away. That's the one that matches. Foil it out to check, but that's the one that matches. So we factor it. Can then take each factor and find out what value of W makes that factor 0. And it ends up being a half. Or the second factor could be 0. What value of W makes that up? -6. And our solution then would be -6, half. So our ultimate version, kind of the worst case scenario, is the version of that would be question 15. 5v times v take away 5 should equal 14v plus 8. First thing, I'm going to distribute the 5v. So that's 5v squared, take away 25v equals this guy plus this guy. I'm then going to get everything over to one side, so the whole equation will eventually equal 0. So I'm going to do that by subtracting 14 from both sides. Well, if you subtract 14v from -25, you get -39v. I'm going to also subtract 8 from both sides. So my first goal is to get the entire quadratic equal to 0. Now, since that is 5v squared, I know that's going to be a 5v, 1v split. I know this number is -8. So basically, I'm going to +1, -8, -1, +8. Then I'll switch places. A negative and a plus and a negative. So there's 4 combinations. Of course, there's one more combination I haven't dealt with, and that's the 2, 4 combination. So 2 is a -4. A -2, we have +4. Switch places, a -4 and a +2, and a +4 and a -2. 2, 4, 6, 8. There are 8 possible combinations that would work with this one. So I'm going to look at some clues here. The biggest clue to me is that this number is really large. Because this is large and negative, I'm going to put -8 there, because that gets me, what, -40, and then +1 pulls it back 1. So that's a combination that works. Now, if this was a small number, I'd probably be looking at one of these combinations. But it was a big number, so that was my clue to go this way. In fact, now that I see it, by sheer coincidence, it happened to be that one. Well, you take each piece, each factor, and you say, okay, that should be 0. Subtract 1 from both sides. Divide by 5, there's one of your solutions. You take your second factor, and you make it 0. And the value of v that makes that happen is 8. And so your 2 solutions would be -1/5, 8. And that is pretty much us covered the main techniques for solving a quadratic equation by essentially factoring, algebraically as they describe it. But as you notice, it's pretty much that you factor is how you get the answers. So I hope that was useful, and hopefully you'll stay tuned for the next video. Bye-bye for now.